Hello, Mr. Malo here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on analyzing functions from a pre-calculus perspective. And if you find this video helpful, please consider smashing the like button, subscribing, and checking out some of my other videos. So let's get going. So today we're going to be talking about what it means for functions to be increasing and decreasing. But to do that, we need to start off with what is our definition for a function increasing and decreasing. So we're going to say a function f of x is increasing if as x increases, then so does the function. And as we're going to say it's decreasing if as x increases, then the function decreases. So what this definition really means is the following picture. Imagine yourself walking on the function. So I'm going to put a little picture of myself over here. So little stick figure me. And whenever you walk on a function, you're always going to walk to the right or in the positive direction. And we do that because we're really positive individuals. Or on this section of the function, I would be walking uphill. So that means at this spot, my function is increasing. If I move a little bit farther along my function to the right, if I'm walking right on this segment, I see that I'm walking downhill. So this is a segment where our function is decreasing. And you can be increasing and decreasing in more than one location or interval. So over here, you'd be walking uphill again. So we'd be increasing. And again, I would be walking downhill over here. So I'd be decreasing here. So a function can be increasing and decreasing on multiple parts of it. And you want to think of it as you're increasing when you're walking uphill, and it's decreasing when you're walking downhill. But it's important to think about this as you're walking in the positive direction. Now, when you're asked to describe where your function is increasing or decreasing, you're going to always do that by discussing the values of x. So what that means for us, we need to analyze what are the values of x at spots like this, where I would go from walking up my hill to then walking down a hill. So we have three locations on this function. I'm going to call them A, B, and C. So these are the different locations where I'm going to go from increasing to decreasing. Now, if I want to talk about where my function is increasing, I need to describe this to somebody. I can do that using my interval notation or my inequality notation. In interval notation, I'm going to say I'm walking uphill from negative infinity, because as far to the left as we can go, I would be walking uphill when I start walking, up until that spot at A, and I'm putting a soft bracket because I'm not including that value of A there. Then I'm walking uphill again from B, so I'm going to put a little soft value for B, until I reach that location at x is equal to C. And since I'm doing it on both of these intervals, I'm going to put a U between these intervals. U means union. It's happening in both these locations. And if you didn't like this interval notation, you could always write it in your inequality notation too. So we're increasing when x is less than A, or, so or is equivalent to my union symbol, when x is between B and C. So that's where I'm increasing. I am decreasing when I'm walking downhill. So starting at that spot A, and I'm using my soft bracket, my non-inclusive one for interval notation. And I'm decreasing up until I get to B. Then I just decrease again from that location at x is equal to C. And then I'm going to keep decreasing no matter how far I walk, so I'm walking downhill. So I'm going to have that go to infinity. And again, I'm going to put my little union symbol there. And if you don't like interval notation, you can say, okay, well, my function's decreasing from A to B, as well as when x is bigger than c. So these are the x values that describe where our function is increasing or decreasing. Now, I didn't include a, b, or c in any of these because it's not clear where you should attribute those values to. Do I include the a in the increasing category because I was increasing until I got to that spot? Or do I include it in the decreasing intervals because that's where I start to walk downhill? And since it's not clear, you have that kind of conflict of interest, we just decide we don't include any endpoints of intervals when you're talking about increasing and decreasing, just to make things simple. So let's look at an actual function now that you might analyze in class and talk about this. So I have a function, which you can see the equation for over here on the left in Desmos that I've graphed. And if we were to picture ourselves walking on it, and we always walk to the right, you're going to be walking uphill right until this spot here. So when x is about 0.31, then you start walking downhill on your function until you get to this location where x is about 2.69, and then you begin increasing again. So in this picture, you would say that you are increasing from negative infinity to 3.1, so 0.31. And so that would be your first interval. And then you'd be increasing again from 2.69 to positive infinity. So, that's what you would write for where you're increasing. You would say you are decreasing from 0.31 to 2.69. So, and here's the notation you would write for where you're increasing or decreasing on the left-hand side. We were increasing up until x was 0.31. Then we waited and we didn't start increasing again until x became 0.26 or 2.69. And then we were decreasing in between them. So I hope you found this video helpful. And if you did, smash the like button, check out my other videos, and have an awesome day.